Hello everyone. This lecture is exclusively recorded for third year BSc student of BK Birla College, Kalyan. This is mathematics class paper 1. In this lecture, we will state the Stokes theorem and we will solve the problem based on Stokes theorem. So let me write down the Stokes theorem statement. The statement is as follows. Let capital S be a smooth, simple, oriented surface with the boundary C let f is a function from U subset of R3 to R3 be a continuously differentiable vector valued function defined on open connected set capital U containing the surface S and the boundary C. Then the line integral of C f d alpha, where alpha is a parameterization for C, is same as the surface integral of curl f dot n cap ds, where n cap is unit outward vector to S. We will not prove this theorem in this lecture now. We will prove in the class. But what I will do now, I will try to solve we will solve the problem based on this. So we assume the theorem is valid, or in fact it is valid theorem, and with we consider this theorem and we will solve the problem based on this. So there are three types of problem can be asked. So the type 1 could be evaluate line integral of f. I think it should be small f. I have written small f. So f dl. So what it means? It means you basically here evaluate line integral using Stokes theorem. So what does it mean? It means evaluate surface integral of curl f dot n cap ds. So evaluating line integral using Stokes theorems, it means that you're supposed to evaluate surface integral. Second question could be evaluate surface integral of curl f dot n cap ds. What does it mean? It means evaluate line integral of f. And third question could be verify Stokes theorem. So I'll write ST, that stands for Stokes theorem. Shortcut. So verifying Stokes theorem means you need to evaluate left hand side, you need to evaluate right hand side as per the normal way of calculation and check whether they turns out to be same or not. So line integral we know how to evaluate. Similarly, we know how to evaluate surface integral. So uh, that way you calculate both the integral and see whether they turns out to be same or not. So we will have example based on the Stokes theorem now. So the question is as follows. Suppose capital S is the part of the plane x plus y plus z is equal to 1 in the first octant oriented with the upward pointing normal and let capital C be its boundary oriented counterclockwise direction. Counterclockwise means anti-clockwise direction. Counterclockwise when viewed from above. If f of x, y, z is equal to x square minus y square minus z square minus x square, then verify Stokes theorem. Okay, so let's draw the diagram. It's a tetrahedron. X plus y plus z is equal to 1. So tetrahedron, I can easily locate the 3 points. So this is z axis, this is x axis, this is y axis, this is z axis, this is 1 0 0 0 1 0 0 0 1. So I can easily locate the 3 points from the tetrahedron, and then we can draw. So we have to take the only region which lies in the first octet. So let me first evaluate the line integral part. So line integral along C solution. So now here C consists of this C1, then this is C2, this is C3. So C is basically C1 union C2 union C3. Okay, so what is C1? C1 is line segment joining 0, 0, 1 to 1, 0, 0. Similarly, C2 is again a line segment joining 1, 0, 0 to 0, 1, 0. And C3 is line segment joining 0, 1, 0 to 0, 0, 1. So these are the three curves we have. So let's find out the line integral along C1. This we will calculate first. So I need to have a parameterization. So let alpha from this to R3 be a parameterization for surface for the line segment C1. So how alpha t is defined? That we know the formula for a line joining 2 points, so that's 0, 0, 1 plus, that formula is some a plus b minus a times t. So suppose this is my a, this is my b. So then 1 0 0 minus 0 0 1 times t. So it is 0 0 1 plus 1 minus 1 minus 0 is 1, 0 minus 0 is 0, and 0 minus 1 is minus 1 times t. Then multiply t and then add it. So I'll have t comma 0 comma 1 minus t. So the range is, we know for this parameterization, range is always 0 to 1. Because if you substitute t is equal to 0, you will get first point. If you substitute t is equal to 1 here, you will get 1 0 0 0. Fine. Now if the alpha t is cleared, then we will find out now f of alpha t, because there are some steps which one supposed to follow line integral. So of alpha t, that is f of t comma 0 comma 1 minus t, that is function is x square minus y square, y square minus z square minus x square. So it is t square minus 0 comma 0 minus 1 minus t whole square comma 1 minus t whole square minus t square. Then this is same as one can use. Okay, so f of alpha t dot product with alpha dash t, that will be so t square comma 1 minus t square comma this will be some 1 minus 2t plus t square, so 1 minus 2t, so t square will get cancelled, dot product with alpha dash t. From this we can find out alpha dash t 0 1 minus t, so that's derivative is 1 0 minus 1. So let's multiply this. So if I multiply this, then I will get t square plus 0 times 1 minus t square plus minus 1 times 1 minus 2t. Okay, so this will give me t square minus 1 plus 2t. And then evaluating line integral won't be difficult. Line integral along C1 f is equal to 0 to 1 f of alpha t dot alpha dash t dt, which is 0 to 1 t square minus 1 plus 2t dt. And then the integral of this is t cube upon 3 minus t plus 2t square upon 2. T will goes from 0 to 1, and it is 1 by 3 minus 1 plus 1 minus 0. So this will give me answer as 1 by 3. So line integral along C1 f is 1 by 3. So now since C1 I have calculated, I don't feel to calculate now to give you the demonstration for C2 and C3, that you can do now, and I can write down the answer here. Similarly, here line integral along C2 f, that will again turn out to be 1 by 3, and C3 f, fortunately here the coincidentally all the line integrals C1 C2 C3 turns out to be 1 by sorry, it is 1 by 3, not 1 by 2. So that you can verify, and we can answer, we can cross check this in the class. So line integral over CF is equal to C1f plus C2f plus C3f. This is 1 by 3 plus 1 by 3 plus 1 by 3, which will give me as answer as 1. Okay, so that's not difficult. Now surface integral part I need to define now. Okay, so I need to have a parameterization first. So it's for the surface integral, if I go for the parameterization for this tetrahedron, whose equation is x plus y plus z is equal to 1, then it is parameterization will be x comma y comma 1 minus x minus y. So now we have to find out surface integral of curl f ds. Okay, so solution. So let alpha from T subset of R2 to R3 be a parameterization for surface S. So let's, what is defined, alpha x comma y is given as x y 1 minus x minus y. So I can easily find out dou alpha by dou x is equal to 1 0 minus 1 dou alpha by dou y 0 1 minus 1, and then I can evaluate the fundamental vector product, that is dou alpha by dou x cross dou alpha by dou y. So that we can easily calculate. So now here I'm not calculating. Okay, let's calculate. It's just 2 minutes task. I j k 1 0 minus 1 0 1 minus 1. So I times this is 0 minus 1 minus minus plus 1 minus j times minus 1 minus 1 plus k times this is k 1. So ultimately we got 1 comma 1 comma 1. Okay, so now what is the, how to evaluate this now? This definition is basically, we know surface integral f ds. Now it is curl f ds. So it will be then surface integral over t curl f evaluated at alpha, say x comma y, dot product with dou alpha by dou x cross dou alpha by dou y, and then dx dy. So I need to evaluate curl f, then curl f evaluated at alpha x comma y, then dou alpha by dou x, dou alpha by dou y, then fundamental vector product, and then we have to take a dot product. So let's find out curl f now. Curl f, which is equal to grad cross f. So cross product of grad and f. So I j k dou by dou x, dou by dou y, dou by dou z, and here f is x square minus y square minus z square minus x square, so which is same as I times, this is 0 minus minus 2z minus j times minus 2x 0 plus k times 0 minus 2y. So curl f is of following way, it is following. So it is 2z comma 2x comma minus 2y. Okay, am I correct? Here it is, yeah, minus minus plus, it will be plus 2y. So then curl f at alpha x comma y I need to calculate. Curl f at alpha x comma y. Now this, whatever curl f we have here, this curl f is basically evaluated at x comma y comma z. Okay, so now we want to find out curl f at alpha x comma y. So how will I do this? This is same as curl f. Now we'll have write down first x, y, and z is 1 minus x minus y, and then apply the curl f definition. So it is, this is my x, this is my y, and this is my z basically now. So according to definition, my curl f will be, so We have already defined what is curl f. So it is 2z. So 2 times z is 1 minus x minus y, comma 2 times x. So x is x only here. So 2 times x and 2 times y. So y is y only. So 2 times y. Okay, so curl f is basically, let me write down, it is 2 minus 2x minus 2y, 2x, 2y. Then curl f dot product with curl of alpha x comma y dot product with dou alpha by dou x cos dou alpha by dou y. This is same as 2 minus 2x minus 2y comma 2x comma 2y, and dou alpha by dou x cos dou alpha by dou y we have already calculated, that is 1 comma 1 comma 1. So then it will be 2 minus 2x minus 2y plus 2x plus 2y. So this will give me 2 only. And now here, then therefore the surface integral s curl f dot ds is equal to double integral over t curl f at alpha x comma y dot product with dou alpha by dou x cross dou alpha by dou y dx dy. And we have already calculated this factor completely. So this is double integral over 2 dx dy. Now what is t? T is very clear. If you take the projection of this tetrahedron in the xy plane, then it will be a straight away triangle. So this is how my t is. So here it is 1 comma 0 and it is 0 comma 1 on the xy plane, and this is x plus y less than equal to 1. So this is same as this, we can easily evaluate double integral with the type 1 or type 2, but this is same as 2 times area of t, so which is 2 times the triangle. The area of a triangle is half into base is 1, the height length is also 1, so it is basically 2. So the surface integral s curl f dot ds, this also turns out to be 2, so I should say 1. So let's express this as equation number 2. And what is equation 1 then? Equation 1 is line integral. So from 1 and 2, Green's Stokes theorem is verified. From 1 and 2, Stokes theorem verified. Okay, so one can solve the similar kind of problem. So I just want to give you, that could be a homework, uh, but it is on the same line. So the homework is as follows. Homework. Verify Stokes theorem for plane x plus y plus z is equal to 2 in first octant. Okay, and my function is given as follows: f of x comma y comma z is given as you can take f of x comma y comma z as yeah, it is x raised to 4 xy and z raised to 4. And the even I can give you, so though it is verification, so the surface integral f curl f that are turn out to be 4 by 3, which is same as your line integral f dot ds. So just check whether both way you are getting 4 by 3 or not. That is what one can easily do that, because it is not difficult. So there's another question here, question number 2. Verify Stokes theorem for f of x comma y comma z is equal to y comma minus x comma 0 over x square plus y square plus z square is equal to 9, and z is greater than equal to 0. Right. So what I'll do, I'll solve this question number 2 here. That's because now here I can give you some hints through which you can easily get the answer, and I'm sure that those hints will help you a lot. So my surface is a sphere, hemisphere, not full sphere, whose above z is equal to 0. Now what is C, what is S, that is what I wanted to show you. I want to clarify. So let me have this in some other color. Now my surface is on the hemisphere. It's a, so this yellow part is basically my surface, and the red part is basically my, the direction is not mentioned, so we will take counterclockwise direction. So the boundary is basically C and the surface is S. So according to Stokes theorem, the line integral of surface, the line integral uh, 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 is same as the surface integral of curl f, right? So here the boundary, that line integral, when you are evaluating line integral, you need a boundary. So that boundary is basically this disk, this circle, when x square plus y square. In two dimension it will be a circle. So x square plus y square is equal to 9, whose radius is 3. So how will I, so if I want to find out the line integral of C f d alpha, then I need to take a parameterization, that is alpha. So it will be a circle, so it will be r cos theta. If I use a cylindrical coordinate, x is equal to r cos theta, y is equal to r sin theta. Here z is 0 anyway, so it is r comma theta. So alpha, here it will be r is 3, so 3 cos theta, 3 sin theta, and Yeah, so 3 cos theta, 3 sin theta, and z is 0. So for line integral we need only one parameter. So instead of theta I will say t, because we have used t as a parameter many a time. So sin t and then 0. So alpha t is this, and then rest you can easily calculate. That won't be difficult part now. Uh, then surface integral, how you will evaluate surface integral? For surface Yeah. For the surface integral, you will go follow as follows. Yes. Yes. So then here your parameterization alpha. So it is on a sphere. So use you can use cylindrical transformation or a spherical transformation. So here I will take this cylindrical transformation. So it is alpha r comma theta. So it is x is equal to r cos theta, y is equal to r sin theta, and now here you are taking x square plus y square plus z square is equal to 9. So z is equal to z is equal to 9 under root of 9 minus x square plus y square. So it is 9 under root of 9 minus r square, and the projection will be a disk. So r will be 0 to 3 and theta will be 0 to 2 pi. Okay, so and so if you evaluate, I need to evaluate curl f ds. So curl f dot ds. So if you evaluate curl f dot ds, then this will turn out to be minus 18 pi. And in the previous one, I forgot to tell you what is t. So t is basically your full circle, that so it will be 0 to 2 pi. So this line integral will also give you value as minus 18 pi. So if both the minus 18, both answer you get minus 18, this would imply the Stokes theorem verified. Well, in upcoming lecture we will have more discussion on the Stokes theorem's problem based on the Stokes theorem and the Gauss divergence theorem. Thank you for attending the class.